And hello, today we'll be looking at area from the area and volume chapter. So I suppose I should describe what area actually is. Now, area is commonly confused with volume, so just make sure you can distinguish the both of them. So area is a two-dimensional measurement of how much space a shape covers. Okay, so the first part, measurement of how much space a shape covers. Now, that seems okay, and it's a two-dimensional shape. So what do I mean by that? Well, let's say we have our three examples that I've been going back to multiple times. Okay, so you have the height of someone. Well, that would be one-dimensional because we're only going up or down. We're only measuring how tall or how short someone is. We're not measuring the width. We're not measuring the volume, how much space in reality he takes up. We're just measuring up or down. So that's one-dimensional. If we wanted to see how much space this rectangular sheet covers, now it's flat, and if I want to see how much space the shape covers, I'm measuring how much across and how much down it covers. So that's two-dimensional. So flat shapes, like on the screen right now, those shapes are two-dimensional shapes. Then three-dimensional, I've spoken about this before. Three-dimensional would be something like this. If we were to measure how much water would fill up this water container, well, that's in the real world. It's 3D. I'm measuring how much length, width, and then also height going up. How much, all of that, if I was to fill it with water, how much would it, how much water could be put into it. So that's not 2D, that's 1D. That's also not 2D, that's 3D. So we'll be looking at flat shapes and we'll be seeing, okay, how do we find the area, how much space that takes up. So then the unit of area, so you remember when we were talking about the unit of length, it was just meters or centimeters. But you'll see here, the area of this kind of looking shape, we use centimeters and then to the power of 2, or as we call it, squared. So that would be 20 centimeters squared is how you would read that. Now, why is it squared? Very simply, when we're trying to find the area of something, we break it up into little squares. So see the way I have a square here, and a square here, and a square here on the grid. Each of those squares is 1 centimeter length. So this line here is 1 centimeter. This line here is 1 centimeter, 1 centimeter, 1 centimeter. So it's a square with side 1 centimeters. So it's 1 centimeter squared would be the area inside of it. So what we're actually finding when we look at the area, we're saying how many of these centimeter squares are actually in the whole area of the shape. So we can just count them. So thinking basically we're counting how many of these little boxes, little squares, 1 centimeter squares are in the full shape. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's 20 centimeters squared. So that's where we got the area from. We just counted all the boxes. So the unit of area is centimeters squared or meters squared or kilometers squared, but it has to be squared. So because we're counting how many squares. So in this case, we're counting how many little centimeters squared would be in the whole shape, but we also could be counting meters squared. So in that case, we'd be counting, okay, how many squares of length, of side length, 1 meter, 1 meter, 1 meter, 1 meter are in the whole shape. So this is really, really important. They do take a lot of notice to if you put the squared in. So it's important that you just don't forget it. So how do we calculate the area of squares and rectangles? Because that's what we're going to be doing. So let's say we have a rectangle like this. So it has length 5 centimeters going across and then 3 centimeters down. Well, it's 15 centimeters squared. That's the area because I can just count the boxes. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then there's 3 rows of 5, so that's 15. Now, I did just count the boxes, but what I kind of did there was I said, okay, how many are in a row going across? And then how many rows are there? Yeah, I could have just counted 1, 2, 3, 4, 5, 6, 7, 8, 9, and kept on going, but I said, okay, there's 5 in a row, and then there's 3 rows. Now, how did I get 5? Well, there's 5 centimeters length. Yeah, because that's 5 boxes going across. And then there's 3 centimeters width, so there's going to be 3 rows. So that's where I got 5 times 3, which is 15 centimeters squared. So the formula for area then is length times width. If you think about it, what I did there is I just said, okay, what was the length? Which is 5 centimeters. That's how many boxes will be in the length, or a row. And then how many rows are there? Well, that would be the width. So length times width is going to be equal to the area of any square or rectangle. So then the question is, let's say we had something like this. Now, this is it a rectangle or is it a square? What is it? Well, it's a rectangle. Why? Because there's one side of length 22 centimeters. This side is also going to be 22 centimeters. This is 9 centimeters, 9 centimeters. So think about it. Okay, there's going to be 22 boxes in a row going all the way along here. And then how many rows are there going to be? There's going to be 9. So what's my formula? It would be the length by the width. So that will be 22 boxes and 9 rows. So the area is going to be 22 times 9, or 198 centimeters squared. That's how many boxes there would be altogether, 198. Okay, that's the area for rectangles and squares. What about triangles? So a little bit different now. So now we have a triangle here. And you'll notice they gave me 2 measurements. They gave me the base going along. They said this is 10 centimeters. And then they said, okay, this height, and you notice the little kind of right angle box here. That means it's perpendicular to this. It's at 90 degrees, going straight up vertically. This height from the base to the apex, that's what we call this, the apex of the triangle, that's 6 centimeters. They didn't give us anything else. They didn't give us this length. They didn't give us that length. They didn't give us any of the angles. They just gave us 10 centimeters and 6 centimeters. So how are we going to find the area of the triangle? Well, we're going to be a bit clever. If I drew a line going up like this to the same height as the apex there, and I did it over here as well. Now, what length is that line and this line? Well, this is 6 centimeters going up. This is also 6 centimeters going up. Then, if I added this line going across, now what length is that line? Well, it's the same as the bottom, which is 10 centimeters. So, now, looking at the bigger picture, see the way this line is 6 centimeters, 10 centimeters, and forget about the triangle. If we just go around the whole length of the shape, well, what is that? That's a rectangle. Forget about the thing in the middle. The whole box, well, it's a rectangle. And we can find the area of the whole thing. So, all this blue, we can find. I know that the length is 6, or the length is 10, and the width is 6. So, the area of the full thing, well, it's the length by the width. So, it would be 10 by 6. Yeah, remember I'm doing the whole box now. I'm doing everything inside this box. So the white bit's included. So it's white bit, and then the actual triangle. So 60 centimeters squared is the whole box. But the question is now, we just want the triangle. We don't want these 2 little white triangles. Now, what you need to realize is this. This is actually half of the box. So this is taking up half the amount of area. Now, if you don't know why, you can kind of move these triangles around. This is a little exercise for you. Try and think about it. See this, if I looked at this rectangle here. Yeah? Looking at this small rectangle. This triangle is the exact same as this triangle. if I look at this other triangle over here, this triangle is the exact same as that triangle. So try and reason, why would it be half? Why is this half? Well, this triangle altogether is the exact same as the white space here and the white space here added together. So that means that this area here is half the total box. So we found the total box, we found everything inside the box to be 60 centimeters squared. So it will be half of 60 centimeters squared, and that's the area of the triangle. So if we were to do it again, I'd say, okay, well, not drawing all those lines, I know, well, it's going to be this length, or this height, I should say, which is from the base to the apex. And then we have the base, which is 10 centimeters. So remember, this length here was the side of our box. And then the base was the length of the box, the width of the rectangle. So what we did was we found the area of the whole rectangle, which was 6 by 10. So it was this by this. And then we halved it. So we said multiply by half, which is 30 centimeters squared. And wouldn't you know it, that's the area of a triangle. It's half the base. Now, we picked this just because I knew this height. Now, you'll see in other examples, it might not necessarily be along the bottom. Let's say we knew the length of this side, and then it told me the length from the perpendicular length from this line to this apex. Well, this would be my new height. It doesn't necessarily have to be going straight up. It just needs to be a line from the base to another apex. Well, if we have that length, and then we have the base, that would be our base, that would be our height. Then we would plug it into the formula. We'd still get the exact same thing. So the actual, if you look it up in the log tables, it's half the base by the height. So it's a side length by the perpendicular length from a base to an apex. And that would be your area of triangle. And it comes all the way, remember where it comes from? It comes from the box. So we make our rectangle and then we say, oh, well, it's this actual triangle is taking up half the area of the whole rectangle. So that's where we get the area of the triangle from. Okay, here's some recap questions so you can have a go at them. So find the length of the rectangle. So it's given us the area. It's given us a width. What about the length? Well, the length by the width is equal to the area. So we know 12 by the length. So 12 times L is equal to 240. Yeah, because it told us the area is 240. So 12 times something is 240. What is that something? Well, it's 20. So 20 times 12 is 240. How did I get that? Well, if you divided 12 into 240, that's going to be 20. So L is equal to 20 meters. So this is 12 meters, this is 20 meters. Okay, how about find the area of the triangle? Now, as I mentioned, we're not told this length. And we're not told the perpendicular distance from this base to the height, or to the apex. But we are told this length to this side, and then the perpendicular distance from this base to this apex. So we can still use this. It doesn't have to be, if you imagine we flip the triangle over, we could get the same arrangement as before. So, what is it? It's half the base. The base is 24. By the height, in this case, is going to be 13. So it's half 24 by 13. That's going to be 198 centimeters squared. Don't forget the squares as well. Over here, this is 240 meters squared. This is 198 meters, or 198 centimeters squared.